Equation of the form ax plus by equal to c when a, b, and c are real numbers, a and b not both 0 is a linear equation in the two variables x and y, and its graph is a straight line. So if we want to identify that whether the given equation is linear or not, so if the graph of the equation is a straight line, we can say that this equation is a linear equation. So the linear equation in two variables is simply can be written as ax plus by is equal to c. So two linear equations in two variables considered together form a system of two linear equations in two variables. So here are three examples of system of linear equation. So one is x plus y equal to 6 and x minus y is equal to 2. The other one is 3x plus 2y is equal to 1 and 5x minus 2y equal to 23. The third example is 4x minus 5y is equal to 21 and minus 3x plus y equal to minus 7. So if we use the graphical methods to find the solution of this system of linear equation, suppose we are interested to find the solution of system of equations given in example 1 as x plus y equal to 6 and x minus y is equal to 2. So we need to draw the graph for each equation. So if we draw the graph for x plus y is equal to 6, so then this is the graph of x plus y is equal to 6. This straight line is a graph for x plus y is equal to 6. So this graph is actually crossing y-axis at this point and the x-axis at this point. Okay, if we want to calculate what is the point, so we need to actually count these small boxes. So 1, 2, 3, 4, 5, and 6. So here x is equal to 6 and y is equal to 0. And this point, so 1, 2, 3, 4, 5, 6. So here is y is equal to 6 and x is equal to 0. So then these 2 points can make a straight line. And similarly, for the second equation, we can draw a straight line. So here y is equal to minus 2. This point is 0 and minus 2. And similarly, this point is x is equal to 2 because 2 boxes on the x-axis and y is equal to 0. So joining these 2 points, we have this straight line. And if you observe, these two straight lines are crossing each other at 4, 2. So how we can read this point? So just counting the boxes 1, 2, 3, 4, and on y-axis 2 boxes. So that is why 4, 2 is the solution for both equations, x plus y equal to 6 and x minus y is equal to 2. We can even verify whether this is the solution of these equations or not. So just substitute x with 4 and y with 2. The left hand side will give you as a 6, which is equal to the right hand side. Similarly, if we substitute these values in the second equation, that is x is equal to 4 and y is equal to 2. So 4 minus 2 is equal to 2. Again, this second equation is satisfied. So one of the problem is that the graph of a linear equation in two variables is a straight line. Three possible situations can occur when we are solving a system of two linear equations in two variables. What are these three situations? So these three situations, the first case is that solve one of the equation. Okay, so this what are these three situations? One is that these two lines can cross each other. The other situation is that these two lines can be parallel. The third way is that these two lines actually the one single line. So if these two lines cross each other, we will have only one solution. And if these two lines never cross each other or they are parallel, so we can say there is no solution for both equations. Maybe we have a separate solution for each equation, but not a common solution. And if these two equations cross each other at every point, it means so actually these two lines are not separate but a single line. So then we can have infinitely many solutions. So it's case one. The graph of the two equations are two lines intersecting in one point. So there is exactly one solution, and the system is called a consistent system. And in case 2, the graph of the two equations are parallel lines. So there is no solutions and the system is called an inconsistent system. So if the system has no solution, then this system is considered to be inconsistent. And if the system has only one solution, so then the system is called consistent system. And in case 3, the graph of the two equations are the same line and there are infinitely many solutions of the system. Any pair of real numbers that satisfies one of the equations also satisfy the other equation. And we say that the equations are dependent. Thus, as we solve a system of two linear equations and two variables, we can expect one of three outcomes. The system will have no solution, one ordered pair as a solution, or infinitely many ordered pairs as a solution. Okay, so you need to remember these three situations, and it is easy to identify whether the given system has a solution or not. So next is the substitution method. Solving specific system of equations by graphing requires accurate graphs. However, unless the solutions are integers, it is difficult to obtain exact solutions from a graph. Therefore, we will consider some other techniques for solving system of equations. So first technique is the substitution method. So which works especially well with system of two equations in two unknowns can be described as follows. Step 1 is that solve one of the equations for one variable in terms of the other. If possible, make a choice that will avoid fractions. And number 2, substitute the expressions obtained in step 1 into the other equations, producing an equation in one variable. Step 3 is to solve the equation obtained in step 2. And step 4, use the solution obtained in step 3 along with the expression obtained in step 1 to determine the solution of the system. So here is the example how we can explain this substitution method. So we have the system of equations x minus 3y is equal to minus 25, and the second equation is 4x plus 5y is equal to 19. So solve the first equation for x in terms of y to produce. How we can solve this one? So we can left x on the left hand side and transfer this minus 3y to the right hand side. We have a value of x in terms of y. So 3y minus 25. Substitute 3y minus 25 for x in the second equation and solve for y. So this value of x can be substituted in the second equation. So here 4 into x, 3y minus 2y. You see here plus 5y is equal to 19. So just multiply this 4 into 3, 12, 4 into 25, 100, plus 5 is equal to 19. And then this 12 plus 5, 17y is equal to 100 plus 19, 19. And for y, 119 divided by 17, we have a 7. So here we have the value of y equal to 7. So next substitute 7 for y in the equation. So this equation and this equation, you need to substitute the value of y. So 7 into 3, 21. 21 minus 25, we will have minus 4. So in this way, we have obtained actually the solution, common solution for system of equations. So this solution can solve two equations, both equations. Just if you want to verify that whether the given solution is the solution of these system of equations, so just replace x with minus 4 and y with 7, you will have minus 25 on left side. Similarly, if you replace x here with minus 4 and y with 7, you have a 19 on left hand side, so which is equal to the right hand side. So these two, next example is the similar example we can solve in a similar way. And also this, but here just this example we can revise because this example have infinitely many solutions. So solve the system 6x minus 4y is equal to 18, y is equal to 3 by 2x minus 9 by 2. The second equation is given in appropriate form for us to begin the substitution process. So substitute this y is equal to 3 by 2x minus 9 by 2 for y in the first equation, and we will have, so left hand side is equal to right hand side. So 18 is equal to 18. So it is difficult to find what is the y and what is the x, but we can suppose for a single variable value. For example, if you consider this equation y is equal to 3 by 2x minus 9 by 2. So here you can have x is equal to 1, 2, 3, 4, 5, and you have a corresponding value of y's. So that is why you can suppose x is equal to k. So if you suppose x is equal to k is a real numbers. So k could be in fraction, could be in integers like this one. Then you will have a value of y, 3 by 2 k minus 9 by 2. So just substitute k is equal to 1. You will have this 9 minus 3 minus 6 divided by 2 minus 3, and you will have the solution. So for k equal to 1, x is equal to 1 and then y is equal to 3. So it means there are many solutions. So and just you can select any value of k and you will have a value of y. Actually, uh, uh, because x is equal to k, so you are selecting first the value of x and then you are obtaining the value of y. And next is the elimination by addition method. Let's consider the elimination by addition method for solving a system of equations. So this is a very important method because it is the basis for developing other techniques for solving systems that contain many equations and variables. The method involves replacing system of equation with simpler equivalent systems until we obtain a system in which the solutions are obvious. So equivalent system of equations are systems that have exactly the same solution set. So here we can remember that what is equivalent system? Equivalent systems of equations are systems that have exactly the same solution set. Following operations or transformation can be applied to a system of equations to produce an equivalent system. The first one is any two equations of the system can be interchanged. So these are actually the transformations or operations which can be applied to convert or to find an equivalent system. So number two, both sides of any equation of the system can be multiplied by any non-zero real numbers. And number three, any equation of the system can be replaced by the sum of that equation and a non-zero multiple of another equation. So these three steps are called transformations. Okay. So the following operations or transformations can be applied to a system of equation to produce an equivalent system. So to develop or to produce equivalent system, we need to perform these three steps, or we can perform any of these three steps, or we can perform all of these three steps or any of them. So it doesn't matter. So we can apply this method to the system of given equation. So here in the system of equation, we have two equations. 3x plus 5y is equal to minus 9 and 2x minus 3y is equal to 13. We can replace the given system with an equivalent system by multiplying equation 2 by minus 3. So if we multiply equation 2 by minus 3, we have this minus 6x plus 9y is equal to minus 39. Okay, now let's replace equation 4 with an equation formed by multiplying equation 3 by 2. So then, now let's replace equation 4 with an equation formed by multiplying equation 3 by 2. So if we multiply this equation 3 with 2, we have a 6x plus 10y is equal to minus 18. Okay, 6x plus 10y equal to minus 18. So this 6x will be cancelled with this minus 6, and 10 plus 9 will be 19y, and this minus 18 plus minus 18 minus 39 will be minus 57. So we will have 19y is equal to minus 57, and then for y, minus 57 will be divided with 19. Okay, so this value y will be equal to minus 3, and this value we can put in this equation 5. So if we substitute this value in equation 5, we will have 3x plus 5 into minus 3 equal to minus 9. That is 3x minus 15 is equal to minus 5. Okay, and then we will have this x is equal to 19. X is equal to 2, sorry. The solution set for the given equation is 2 and minus 3. So we can, if we just substitute or replace x with 2, we will have there 4x. And if we replace this minus 3 by y, we have this 9, and 4 plus 9 equal to 13. So it means this is the solution. And similarly, what is the things to remember is that we are using a format for the elimination by addition method that highlights the use of equivalent systems. Okay. The next example is half x plus 2 by 3y is equal to minus 4, and 1 by 4x minus 3 by 2y is equal to 20. The given system can be replaced with an equivalent system by multiplying equation 7 by 6 and equation 8 by 4. So just if we multiply equation 7 by 6, we have this 3x plus 4y is equal to minus 24. So we will have this one. And if we multiply equation 8 by 4, we have this here x minus 6y is equal to 20 into 4, 80. Okay. So then we can have a value of x from here. X is equal to 80 plus 6y, and we can make a substitution of this into the first equation, or we can even write this as a first one and second as a and the first as a second one, so it doesn't matter. You can interchange, no problem. And then x is equal to minus 6, y is equal to 80. Okay, and now we can replace equation 12 with an equation formed by multiplying equation 11 by minus 3 and adding this result to equation 12. We will add 22y is equal to minus 264. And then if we have a value of y is equal to minus 12, because 264 will be divided by 22. And then substituting minus 12 for y in equation 13 produces x minus 6 into minus 12 equal to 80, and x plus 72 equal to 80, x is equal to 8. The solution set of the given system is 8 minus 12. So this can be checked to verify that x is equal to 8 and y is equal to minus 12 satisfy the equation or not. So x is equal to 8, you will have here 4 and y is equal to minus 12. So you will have here again a minus 8 plus 4 equal to minus 4. So it means equation is true, the solution is true. Similarly, we can have this solve the system of equation x minus 4y is equal to 9 and x minus 4y is equal to 3. So on the left hand side, these two, both left hand sides are the same. So we can replace equation 16 with an equation formed by multiplying equation 15 by minus 1 and adding this result to equation 16, then we will have 0 equal to minus 6. So this is not true because the statement 0 equal to minus 6 is a contradiction. Therefore, the original system is inconsistent. So this system have no solution. It has no solution. The solution set is, you can write the solution set is 5 or 0 sets. So that is the elimination method. Now we can move forward to just do some word problems. So here is the first problem is that John Paul always runs his pontoon boat at full throat, which results in the boat traveling at a constant speed, going up the river against the current boat. Against the current, the boat traveled 72 miles in 4.5 hours. Okay, the return trip down the river with the help of the current only took 3 hours. Find the speed of the boat and the speed of the current. So we can suppose that let x represent the speed of the boat and let y represent the speed of the current. So going up the river, the rate of the boat against the current is 72 miles over 4.5 hours. So 16 miles per hour is actually the speed or velocity. Going down the river, the rate of the boat with the current is 72 miles over 3 equal 24 miles per hour is again the speed. The problem translates into the following system of equation that x plus y is equal to 24 and x minus y is equal to 16. Okay, so then we have this system of equation. So simply if we add these two equations, we will have this 2x is equal to uh, 40. So 2x is equal to 40, just adding these two equations, then we have a value of x is equal to 20. And if we substitute this x is equal to 20 here, so we have a y is equal to 4. So 20 and 4 is the solution. So x is 20 and y is equal to 4. So next example is also the similar example. Say Lucinda invested $950, part of it at 6% interest, and at the remainder at 88%. Her total yearly income from the two investment was $71. How much did she invest at each rate? So let X represent the amount invested at 6% and Y the amount invested at 8%. And was the total? Total was the 950. So it means X plus Y should be equal to 950. And then this 6% can be written as 6 by 100, and you will have 0.06, and 8% can be written as 8 by 100. So 8% 0.08y will be equal to the total of rate of interest, so 71%. So 71. So multiple. So we can just multiply the second equations by 100 to eliminate this 0.06, 0.01 etc. So we will have this 6x plus 8y is equal to 7100. So here we have a two choice that if you multiply this first equation with 6 or minus 6, then if you add so the x will be eliminated and you will have this value of y. So minus 6 y, it will be 2y, and minus 6 into 950, and then you will subtract 7100 from minus 950, and you will have 2y is equal to 1400 and y is equal to 700 for y in the equation. So then we can put this value of y in first equation, x plus y equal 950, x plus 700 equal 950, and x is equal to 250. So therefore Lucinda must have invested $250 at a 6% and $700 at 8%. So in our final example of this section, we will use a graphing utility to help. So here, so this example is solve the system 1.14 x plus 2.35 y is equal to minus 7.12 3.26 minus 5.05 26. So it's a simple way is that you just multiply both equation with 100 and you will be freed from this decimal point, because 1.14 can be written as 114 divided by 100, and then you can solve as we have solved these previous examples. We began this section with graphing the equations in a system to find the solution. So there are some techniques available on Google or softwares. So you can even use this technique to solve this such kind of equation. But if you can also use your calculator. So for example, the first equation, this one, can be written as minus 7.12 minus 1.14x over 2.35. So here you can write y is equal to this one. Okay, so then also the second equation can be written in the form of y is equal to this one. So then you need to write these two equation, that is minus 7.12 minus 1.14x over 2.35 is equal to 3.26x minus 26.72 over 5.05, and then you can obtain the value of x by solving these equations. This value is x is equal to 2, and then if once you obtain this value, you can substitute x is equal to 2 here. If you substitute x equal to 2, you will have the value of y is equal to minus 4. So in this way, you have this By direct substitution into the given equation, we can verify that the point of intersection is exactly 2 and minus 4. So there are not a difficult way to solve this equation, but just you make a substitution or elimination by addition.